Hey guys, Mr. Decker here. This is lesson 15, Conditionals. We're in the Computer Science Discoveries Unit 3, Animation and Games, and we are moving right along here. Things are starting to get really interesting and fun. All right, let's go ahead, shall we? And just so you know, this is the updated for 2023-2024 code.org CS Discoveries curriculum. So if you're new here, you know what to do. Follow along and learn how to code. All right, Boolean expressions. Boolean expressions are expressions that can only evaluate to true or false. So if you're asking a question, right, for code, a Boolean expression is one that you're like, Mr. Decker has red hair, true or false. And that would be true. Whoa. I tried to highlight true, and then I messed everything up. So there you go. That's a good start to it. All right. We're making a prediction. So read the code below. There are some new symbols in it which you haven't been introduced to. Take a guess at what they mean and try to answer the following question. Which result will be printed in the console by this program? So down here is our console. And it's going to tell us whether the Boolean statement is true or not, or Boolean expression. So let's take a look at line 5 here. In console.log, that means it's going to print it down here. Sprite1.y is equal to sprite2.y. Sprite1y is equal, so that first one's going to be true. B is no. C, no. D, no. So we already know that A is the correct answer based off of just reading line 5. So on line 6, console.log sprite.1x is greater than sprite.2x. So sprite1x is 100, sprite2x is 300, so that's false. So we're still good on selecting A as our answer choice. Console.log sprite1.x is less than sprite2.y. Sprite1's x is 100, sprite2's y is 200. That is a true statement. There we go. Run it. There they are. Finish. Congratulations, you completed puzzle 1. Let's move on to bubble 2. Ooh, okay. Let's zoom into this. All right. Match the Boolean expression to the English description. So we're comparing operators. Let's see. Is the dog sprite's rotation less than the cat sprite's rotation? Rotation, here's the only one that says anything about rotation. So let's use that. And it does use the less than symbol, like it asks for. All right, is the dog sprite's x less than the cat sprite's x? That's this guy right here. Is the dog sprite scale greater than the cat sprite scale? That's this guy right here. Is the dog sprite's x greater than the cat sprite's x? That's you. And then is the dog sprite's x equal to the cat sprite's x? If I haven't mentioned it before, one equal sign in JavaScript, it means gets, and two equal signs together means, what was it? Equals. Good. All right. Let's move on. Bubble 3. Let's do some actual code here. Come on, man. All right, this level follows a video that you may have watched with your class. All right, Booleans. The program draws a race car and a finish line. Let's run it. So there's our race car. Here's our finish line. It's a very well-defined finish line. It even says finish really big on it. Is that a sprite? Let's go to the animation tab. It is a sprite. All right, sweet. Let's make this work. So the program draws a race car and a finish line. We're going to figure out when the race car crosses the finish line, and the sprites have all been set up for us. Yes, they have. Thank you very much. We need to find out if the race car has crossed the finish line. I'm going to zoom back out because my goodness. There we go. All right. We're going to add blocks to the text command to print the boolean to the screen. So we're going to add a blank is greater than blank block, or blank is less than blank block, to the text parameter of the text block. Whew. So here's the text, right? Right. Add a less than block to the text parameter of the text block. Of this block? Okay, yep. So here's the text down here. Add blocks to the text command to print the boolean to the screen. So yes, so right here, math, where are you? Where are you? I need that less than symbol right here. And then we're going to add sprite.x to both sides. Okay. And then make sure to update sprite.x blocks with the names of the two sprites so that the boolean is asking, is the x of the race car less than the x of the finish line? So x of race car finish line. I hope they used camel case. Yes, they did. All right. So is the race car x value less than finish line x value? Make sure to update the sprite blocks with the names of the two sprites, right? And then the text block should now look like this. It should look like that, folks. It should look like that right there. Let's see if we can refresh it and get that going. Nope. Okay. Good job, code.org. All right. Watch the Boolean output that is now printed on the screen as the car moves. Discuss with your neighbor, when does the output change, and most importantly, why. So if we run it, right now it's false. And eventually it's going to be true right there. We have crossed the finish line. We'll run that again. True. All right. So it's like false, 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 until it's true. All right. Very cool. When does the output change, and most importantly, why? Well, it changes when the race car's X, which is right in the middle of the race car, passes over the middle of the finish line. Let's watch that again. And true. Good. Finish. Continue. On to bubble 4. And on bubble 4, we have an if statement here. Something's supposed to be there. Boolean expressions. Let me see. If I right click on it, load image. Nope. Open image in new tab. There. Okay, so that's what it's showing us. Or trying to anyway. An if statement. Boolean expressions allow us to ask questions, but in order for us to use those questions to change the program's behavior, we need an if statement. Oh, so this is a prediction. Okay, so do this. Read the code for this race car program. All right, reading the code. What will the program do when the car crosses the finish line? All right, so if race car's X is less than finish line, that's the same Boolean expression we used on the last bubble. And then text, the orange car is the winner, will appear at 100, 100. Oh, okay. Well, that's simple. So we're answering two questions. What will the program do? Okay. Caps lock, the orange car is the winner. Oh, exclamation point, quotation marks, will be printed in the display area at 100x, 100y. And then the next question, why is the if block inside the draw loop? The if block is inside, oh my goodness, the if block is inside the draw loop. Me and typing today, struggling. If the block is inside the draw loop, or the if block is inside the draw loop, because the program needs to check the Boolean expression over and over again until it becomes, not until it becomes, to make sure the true false evaluation remains accurate at all times. And that is a very thorough answer. Holy majoli. All right, so the orange car is the winner, will be printed in the display area at 100x, 100y. And the if block is inside the draw loop, answering this question here. If the block is inside the draw loop, or the if block is inside the draw loop, because the program needs to check the Boolean expression over and over again to make sure the true-false evaluation remains accurate at all times. Run. And it should print that text to the screen now. The orange car is the winner. There it is, folks. All right, let's finish. Let's go to bubble 5. On bubble 5, okay, your teacher might be making you watch a video right there, but we're moving on. Now that we know how to use if statements, you can do more than just check if the apple has reached a scale of 2. You turn it into a pair once it happens, okay? So we're using an if statement to turn an apple into a pear once its scale is greater than 2. So use an if statement inside the draw loop. Let's do that down here. So control, boop, there's that if statement. We're checking whether fruit scale is greater than 2. So the first thing we need to do is go find greater than in the math drawer. Now we're going to go to the sprites drawer and grab scale. Match that variable label so the computer knows what we're talking about. When its scale is greater than 2, all right, and we're going to add code to the conditional statement. We did this part already. Add scale block to the left side of the greater than operator, then type the number 2. We did that part. And then make sure we update the name of the sprite in the scale block. We did that part. All right, we're on step 3. Add code inside the conditional to change the fruit to a pear. Add set animation inside the if statement. There you go. And then this is going to be fruit as well. So we're changing that fruit animation to a pear. And it should have started out as an apple at the beginning of our program. As it grows, it'll become a pear, as happens in real life. That's just, common knowledge that when apples become adults, they turn into pears. All right, set the animation to a pear. What should my final if statement look like? Should look like if fruit.scale is greater than 2. Yep, if fruit.scale is greater than 2, then fruit.set animation is pear. Run. Come on, Apple. You can be big. Go, Apple, go. You can do this. There we go. Excellent work, everybody. Give yourself a pat on the back, a round of applause. There you go. Do the gritty, whatever it is you do when you celebrate. All right. Bubble 6, we've got some practice levels to get through. Let's do level A, Boolean expressions. Seems we have a common theme here. Boolean expressions. The simplest Boolean expressions are questions that the computer can answer with true or false. Another way to say this is that Boolean expressions evaluate to true or false. Do this. Modify only the values of the sprite properties in the first 11 lines of code. Okay. So that each of the Boolean expressions evaluates to true. Look at the first 11 lines of code to see which properties of sprite 1 and sprite 2 are being used and their values. For each of the Boolean expressions on lines 16 through 20, identify the sprite properties being compared and change the code in the first 11 lines only so that each of the comparison statements will print to true on the screen. A lot of instructions, but to make it very simple, we're checking these Boolean expressions. So if I run it, right, comparison 1, false, 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 false. We're trying to get all of those to be true. And to make that happen, we've got to change values up here. Comparison 1. Sprite 2's x is equal to sprite 2's y. Okay, so sprite 2, so let's change this to 300, and then that should equate to true, and it did. All right. Next comparison, sprite 2's rotation is less than 40. So rotation is right here on line 10. Let's make that 39. Reset run. That's true now. Comparison 3, sprite 1 scale is equal to sprite 2 scale. 1.5 and 0.5. Let's change this to 1.5 to make those equal. So that's true now. Comparison 4, sprite 1 x is greater than 150. 151. Reset run. That is now true. Comparison 5, sprite 2's y value is less than 200. Sprite 2y less than 200. So 199. Reset run. Oh, but comparison 1 just became false. What was comparison 1? Sprite 2.x is equal to sprite 2.y. So I need both of these to be 199 now. There you go. Oh, look, they're friends. They haven't seen each other in a long time, that little apple and that little carrot. Okay. They really leaned in for this embrace. All right, let's finish. We got everything to be true. Let's head over to level B, the dropped soup. Don't drop your soup, man. That's tragic. All right. Add a conditional if statement in the draw loop to make it look like the soup spills out of the bowl when it turns upside down, like in the image to the right. There's our image to the right. Okay, let's open that in a new tab. See what that looks like. All right, it's going to gloop out of the bowl or fall out of the bowl once it turns upside down. So we need an if statement checking the rotation. Run the program, see how it works. We did that. Add a watcher to see the rotation value of the bowl and note what the value is when. Okay, so we'll do soup.rotation. We'll watch that. So when we run it, and we want it to, let's run that again. Boom. What was it? It's hard to look over here and over here at the same time. If I could get my left eye to focus on this and my right eye to focus on this, would be good, but I am not that awesome. All right, where is it? Okay. Upside down. Oh, it's upside down at like 130 maybe. Okay, so add a conditional that detects when the bowl is upside down. Add an if statement. If statements are in the control drawer. Let's add that if statement. That will check if the value of the bowl's rotation property is greater than the value you made note of in step 1. So let's go to math. Greater than, right here, sprites, sprite.rotation, right here. We're checking on the soup's rotation. See if it's greater than 130. And if it is, we're going to change the soup's animation to be just the bowl. Just a bowl. All right, run. Empty. Good. Haha. I solved the problem. All right. And yep, we did it all. We did it all. Boop. Boop. Excellent. Continue. We are now on C, alien celebration. When aliens celebrate, that might be a problem for me, maybe a problem for you. I don't know. It really depends on what they're celebrating. What are we celebrating? Use a conditional to make the alien dance when the spaceship reaches the top of the screen. So he's going to be happy when the spaceship gets all the way up there. All right. So let's do it. We can do this. We can do this. We need an if statement. We're checking some math. We're seeing, so y decreases as you go up. So less than Sprites, we're checking the spaceship.y is less than, let's say, 30 when it's at the top of the screen, and we want the alien to dance. Okay, so we're going to set the animation to alien dance. So right now, he looks annoyed, right? Look at that facial expression. Let's make that bigger. Look at this guy. He's just like, spaceship, humans. All right, let's see. We want to change it to alien dance. We can slow down his dance. We can speed up his dance. Whoa, a little too excited there, guy. All right, right there's probably good. He's super excited about a spaceship. He's annoyed right now. All right, set that animation. He is the alien. We're setting his animation to alien dance. Run. Boom, he's excited. All right. He gets some free time. The teacher flew away, or his parents went off on a business trip, and now he's got the whole forest to himself. Planet, I don't know. Yeah, we got it. All right, let's head over to the next one. Bubble 7, that's your assessment bubble. That's this guy right here. All right, use an if statement to make the dinosaur turn into a pterodactyl when it reaches the sky. All right, so right now, it's, the aliens were on the last bubble. Is this dinosaur getting beamed up? All right. Sprites. No, first thing I need is a control. I need an if statement. We need some math. We're going to go less than. We're going to go less than again. And we're checking on y. So this is kind of the same thing we just did. Dinosaur. And dinosaur.y is less than. Let's turn him into a pterodactyl when he's. I know, errors everywhere. Let's just do 200 here. And we're gonna set the animation, Control C, Control V, to the pterodactyl. It's already living over here on my animation tab, making it pretty easy to do the work. There he goes. All right. So as soon as he's off the land and to the top of the mountain, he's now flying away. Just T-posing into the sky. Boop. There you go. Finish. Is that wait. Keep playing. Is that all I wanted everybody? Set the sprites animated. Yep, that's what I want us to do. Good. All right, that's going to put us on bubble 8. We've got a lot to accomplish here. Let's get through it. We've got this. We have the energy. We have the technology. And dang it, we have the brains. Let's do this. New block visible. Sometimes it's useful to hide the image for a while and then have it appear when you want. You can do this using the visible property. The visible property is let's do this again. All right, we got a balloon. And the balloon is going to pop. All right. Okay. So do this. It says use the visible property inside an if statement. So let's make our if statement. Get out of my way. Control drawer, if statement. And we're going to make the balloon pop when it hits the edge of the game area. Create a pop sprite, which uses the pop visual. There's pop. Oh, okay. Sprites. I see. Create my pop sprite. Pop. Pop, 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 pop. Pop. Pop is going to be pop. And set the pop sprite to be hidden at the beginning. Where are you hidden? Where visible? There you go. Sprite.visible. Pop.visible is going to be false at the beginning. And we're going to add a conditional that checks the size of the balloon to see when it touches the edge of the screen. Okay, add a conditional that checks the size of the balloon to see when it touches the edge of the screen. So we're going to check on the balloon's scale. So world, no. Drawing, no. Math, maybe. Variables, here we go. Console log. We're checking to see, oh, we're adding the conditional that, wait, what? Checks the size of the balloon to see when it touches the edge of the screen. Oh, okay. Okay. All right. So greater than when balloon.scale, balloon, see when it touches the edge of the screen. I don't know what the size will be yet, but let's say greater than 2 for now. And then inside the conditional, set the balloon sprite to be hidden and set the pop sprite to appear. Okay. So we're going to change the animation of the balloon pop. Or wait, inside the conditional. Do I need to have the balloon set to hidden? Oh, I see. Okay, I see how it wants it to be done. So sprite.visible, balloon. There's more than one way to do this, but we'll do it the way that they want us to. So balloon.visible will be false now, and the pop.visible will be true. Let's run it. We'll see what size we need to get it to before it pops, because we don't want it to pop until it touches the edge of the screen. Okay, clearly something's not working here. If balloon.scale is greater than 2, then balloon.visible equals false and pop.visible equals true. Uno momento. All right, so I think this number is just way too big. Let's try 0.5 for when it pops. Also, I want the balloon to grow a little bit faster. Let's double the rate, because that's really slow. Still kind of slow. Okay, so it did that too early. Let's try 0.6. Actually gonna make this increase a little bit faster while we're testing the program. What? 3. Reset run. When does it pop? When does it pop? It's close. Let's try 0.7. And pop. Okay, that's too big. 0.67. Let's see how exact that is. Spending a long time on this balloon project. Boom. Perfect. All right. Or pop, rather. Perfect. Pop. Perfect. Finish. All right. Restart sprites. We're going to use conditionals to wrap sprites back to where they came from. Back to whence you came. All right, restart the sprites. Many times you will want a sprite to go back to where it started once it reaches the end of the screen. We can accomplish this with our conditionals. Do this. Use if statements to make the ghost and monster sprites wrap back around to the right side of the screen if they reach the edge of the left side of the screen. Okay, so run. Oh, they're not even moving. So we got to make them move. Whoa. Okay, so okay. So we're going to use the counter pattern to make the ghost and monster sprites both travel from right to left. So over here to over here. All right, so sprite.x, we've got a ghost and a monster. Simple enough. Let's make the ghost move. So ghost.x gets ghost.x minus. Since we're moving left, we're subtracting on x. So ghost.x minus 2. And then our ghost is apparently running away from a monster. We'll Control C, Control V. We're just going to change monster, set run. All right, now they're moving. What else? Add a conditional that checks to see if the ghost sprite has gone off the left side of the screen. Okay. Control. Here's our conditional. We're checking to see if he's gone off the left side of the screen. So math less than. So if we're moving left, we're checking to see if it's less than. So once he goes off the screen, so it's going to be ghost.x. It's less than 0. He's gone off the screen. Inside the conditional, reset the ghost sprite's location to the right side of the screen. So if ghost.x is less than 0, then ghost.x is 400. Reset run. Let's make sure that's working. Hey, look, the monster has a little shadow. The ghost does not. All right, that's working. And then the last instruction, repeat steps 2 and 3 for the monster sprite. So, all right, so boop, Control C, Control V, and we're just going to change this to monster and monster. And then that should work. Yep, cool. They're just going to loop forever. Eventually they'll get tired, maybe. I don't know. Do sprites get tired? It's a computer program. It never gets tired. All right. No lactic acid buildup, nothing. They can run forever. I'm going to sign these ghosts up for a 5K, for a 10K, for the Boston Marathon. All right, let's finish and continue. That's putting us onto never-ending fish scene. This is the fish that never ends. All right, let's make an underwater scene with fish that never stop swimming. Just keep swimming, just keep swimming. Dory would be very proud of what we're about to make, I think. All right, let's make an underwater scene with fish that never stop swimming. We're revisiting our fish scene with some new fish to make this scene. Here, we got this again. Got a problem, son. All right, so they're just going to loop and loop and loop. Everything's looping. What did I do? Oh, no. What did I do? Okay. Let's make an underwater scene with fish that never stop swimming. We're revisiting our fish scene with some new fish. Use if statements to make 2 of the fish sprites wrap back around once they go off the screen. Okay, so I've got these guys here. Make 2 of the fish wrap back around. Okay. Pick 2 of the provided fish animations and add your own sea creatures, or add your own sea creatures. That's important. That's an important or, not an and. Move each sprite in a different direction. Okay, so we're going to make this guy go left, and we'll make this guy go right. Okay, so let's animate sprites, sprite.x, sprite.x, and we're checking less than for this guy and a greater than for that guy. So we'll do less than here and greater than here. All right, what are the names of these fish? We've got green fish and blue fish is what we're operating with here. So green fish, capital fish, and blue fish, capital fish. That's a Mr. Bluefish, okay? And we're seeing if it's greater than or less than. So here, green fish, control C, sprite.x again, sprite.x again, or wait. No, we're making a move. What are we doing right now? What are we even? Okay. Green fish, control C, control V. No! Oh my gosh. Oh my gosh. All right, y'all. My brain. Blue fish, we're adding. Green fish, we're subtracting. I apologize. Okay. If you've been pausing and repeating these steps, I'm sorry. We're good now. We're good now. Brain is turned back on. Okay. Xing and Xing. Control C, Control V, Control C, Control V. We'll give them a slow speed of 2, reset, run, just to make sure they're moving. They are. Good stuff. All right. Add a conditional for each of the sprites you chose that will check if the sprite has gone off the edge of the screen. So let's get these conditionals going. We need 2 of them. Now we're checking less than and greater than. So for the blue, or yeah, yes, no, yes. Okay. Now we're checking their x values. So green fish is moving right. No, wait. Where are they? Where were they? Will it run just like that? Nope. All right, green fish is going left. Blue fish is going right. All right, let's do this one at a time. Blue fish is going right. Let's do blue fish first. So we're checking if he is greater than. If bluefish is greater than 400, then bluefish is going to go back to 0. Make sure that works. You can do it, bluefish. I believe in you. Okay, that's working. All right, so I'm going to control C this, control V it right here, but I'm going to change it to green fish. So control C, control V, control V. Then we're going to show text, and we're going to change a couple things. So it's not going to be 400. It's going to be less than 0, and we're going to change it to 400. Show blocks, run. So we want that to be kind of the opposite of what we're doing here. Good. All right, they're looping. Okay. You will check either the sprite's X location or Y location. Okay, so we're now going to set their Y location to random. Random Y location. All right, we can do that. That's easy. So sprite.y, greenfish.y. We're going to go to math, grab a random number. We'll set it between 50 and 350. We're going to do the same thing for the bluefish. I love copying and pasting. Reset run. So now they swim past each other. They reset at a new Y location every time. Okay, cool. Let's finish there. Finish. All right. D, we've got 2 more bubbles to go. Let's try to get through these. Come on, code.org. All right. Let's continue making the underwater scene with fish that never stop swimming. Make 2 more of the fish sprites wrap back around once they go off the screen. All right, so we're going to do this guy and this guy. All right. Move each fish sprite in a different direction. You can use this image to the right for inspiration. Okay. Add a conditional for each of the fish sprites you chose that will check if the fish sprite has gone off the edge of the screen. Find the section of code for your conditionals. You'll check the X or Y location depending on the direction. Inside the conditional, reset the sprite's X and Y location. All right. We got this. Let's get that out of our way. Let's make these things move. We've got orange fish somewhere. Orange fish and the starfish. All right, let's make a move. Starfish is going to move on Y. And we're going to say starfish.y plus, to make it go down the screen, 3. Let's make him move quickly. Enter. Reset run. There he goes. All right. And he starts at a random X location each time, so that's good. All right, let's add his conditional now. So conditional statement for the starfish is going to read like this. So we're checking to see if his Y value is greater than 400. And we're going to reset his Y to 0 and his X to a random number. So math drawer between 25 and 375. Let's make sure that's working. All right, cool. And then we got to get our orange fish going here. So back up here, sprite.x, orange fish.x gets orange fish.x minus 4. Let's make him kind of fast. Reset run, make sure he's moving. He is. All right. Let's also make him move on Y slightly. Yeah. Gets orange fish Y. Let's make him move up each time, or nah. We'll just have him show up at a random Y. Orange fish, where are you? He'll always start in the same spot, apparently. No, he won't. Orange fish is random, between 200 and 400. All right. So run. Okay, so now we want to loop him back around. And he's moving left like our green fish is. So we're going to Control-C that, Control-V it. And then we're going to change these to orange fish. Control C. Let's make it quick. Set run. Okay, good. And let's see. Next challenge level. Finish. The never-ending fish scene 3. We're on the last bubble. Let's get this knocked out here. Let's finish making our never-ending underwater scene. All right, we're going to make the starfish, sprite, and bubbles wrap back around once they go off the screen. We've done that already. What other fish did we have? Animation? Oh, we have a shark. Where does the shark start? Minus 150. No wonder I can't see him. Okay. So we're going to copy the blue fish to get the shark working. So Control C, Control V. Sorry, shark called anything other than shark. No, just shark. Shark. All right, we'll give him a speed of 3. Whoops, we'll give him a speed of 3, like I said. And then again, the blue fish, Control C, Control V, and it's going to be a shark. Control C, Control V, Control V. Let's keep him. Yeah, he can go anywhere. Sure. Run. There he is. Shark's a moving. Will he loop? Yes. All right. Everybody's looping. All right. Make starfish fall from the top of the screen to the bottom of the screen. Add a conditional to the starfish checks from the screen. Add a conditional that checks the value of the bubble variable. Okay. Where's the bubble variable? Here. All right. To use a watcher when the last bubble reaches the top of the screen. So we'll use a watcher. Bubble.y not available. What would I do to check that? We'll check the value of the bubble variable. So let's see. Control. So if bubble is less than 0, enter. Right? Bubbles variable rather. Oof. Bubbles is less than 0, because that's the name of this variable right here. Starts at 400. And then where are we making them go up? Up here, okay. And bubbles gets bubbles minus 2. So when it's less than 0, we want bubbles to be 400 again. No. How do we do that? Inside the conditional, reset the bubble variable to its original value. Pause. And we're back. Okay, so down here in this if statement, variables, no. Sprites then? Let's see. And then I pull this out, and we'll say bubbles equals 400 again. So reset run. Let's see. Hey, they loop. All right. Let's say less than like -50. Run that again. So I want this last bubble to go off the screen. Nope. -90. Come on, bubbles. That's pretty close. Let's just do like -110. All right, try it again. Last chance. Come on. Come on, bubbles. Don't fail me now. Sweet. That is nice and smooth. All right. We finished. Our never-ending fish scene is finished. We did it, guys. We did it. All right. Hui. All right, that's it for me. I hope you enjoyed this lesson as much as I did. We're going to move on to lesson 16 next, and I'll see you there.